Hello community, so great that you are back. Today we have a look at the latest regarding chain of thought reasoning. And there's this brand new idea we're gonna talk about, that we should break up those beautiful long chain of thought from our huge reasoning models, And you might say, why? I'm so happy that finally our reasoning models are able to come up with solutions. So if we open up this video, there is now a surprise. Because, this end-to-end, it fills complete computer screens with this full long chain of thought reasoning sequences. And I made a video where I showed you here in real time a 10 minutes long internal reasoning thinking process by the final QWQ32B model, just a huge chain of thought reasoning to solve a task. And now you say, we can take this, we can distill it down, and we can train much smaller AI model with the intelligence of these huge models. We just need to find the perfect methodology to condense this down to the minimal core of a long chain of thought. So think about it. What is the most powerful spine, if you want, in the causal reasoning network? What is the causal reasoning pathways through this complex graph topology? Because this is all that we need. So, let's start up, and we need a spark of genius. And we have a new methodology by beautiful new research, and this research is called Deconstruct those long chain of thought. And you say, this is interesting. So, what we do? We have now a data processing and a new kind of an optimization framework designed to refine those long chain of sequences by isolating here only the key logical pathway and remove the rest. We are interested here in the minimal set of pure logic. Let me give you an example. Just this equation. What is it? And we have here on the left side a Q and QWQ, the preview, so not the latest model, a 32B model. And on the right side, we have our beautiful DeepSeek R1, 32B671B. And you see here the way they answer this. And the authors looked at this and they say here, if we have this in red, this is the ground truth, and in black, we have an incorrect path. And then they analyzed certain argumentation pathways. And they found that we have linear structures, we have branching structure where it's branching out in multiple branches, a tree structure approach, and then we have something like an open net approach. And they said, how can we build here, how can we extract here the minimal set here, the minimal logical set of argumentation to solve all those tasks? And I think it's a beautiful approach, but it has some very interesting consequences. So, 5 ideas for deconstructing long chain of thoughts. The core idea is rather simple, and here you have an image from the original publication. You have a macro structure parsing, so you define the problem statement, the approach, then you have a verification and a summary, and then you start with the approach. So you have here, look how many approaches are there available for a problem, Definition, analysis, verification, summary, but there's another way, there's another perspective I can see this. Maybe I do it in pure mathematics. Maybe I can use some formula from theoretical physics, however you want to use this. And then you say, okay, I have a look at all of the path. I have a look, are there redundant path? Are there an analysis here if I cluster this solution? So if I have a lot of different solutions and a lot of different sorts, if I look at all of them together, can I then design the perfect set of logical sequences so I have a coherent reconstruction and a coherent answer? Let's look at this one by one. Step 1. Divide the long chain of thought into 4 fundamental components. The first is real problem restatement. So whatever I, in my clumsy little English, I'm formulating now, the AI says, okay, listen, buddy, I have to reformulate your stupid question into a clear, structured statement that an AI is able to understand it. Second, the approach exploration. I will now generate multiple candidate approaches for solving your stupid problem, human, Because I am such a genius AI and I can think of minimum 10 different ways to solve this. Then, of course, the AI has a verification step. Validate and cross-check intermediate conclusions, because if you do not arrive at the final result, it doesn't mean that your path was completely wrong, but maybe only the first 60% were in the correct pathway, and then you made a wrong decision, the AI made a wrong decision, and branched out here, and we got a wrong decision. And then, having all these mighty statements here on a data manifold, decision manifold, we summarize it, we condense it, we have a coherent final output. Great. Second step, further decompose here the approach, exploration, and result verification. You remember this? Approach, exploration, and result verification. So the middle two steps now go in detail, in a fine-grained segment structure. Break down complex reasoning into sub-steps, you know this, without being overly constrained by predefined patterns, and you know what is happening. Third step, identify and remove all the repetitive or overlapping reasoning path, but try to maintain here a kind of a diverse set of valid strategies. I don't want to have the identical solution to all the different problems, but show me a variety of strategies. Show me a variety of paths to a solution, because I want to be a genius AI, no? So what we do? The AI is clustering all of its possible answers and looks, hey, what answers are kind of similar? So in a cluster, maybe I just go for the dominant trace in a cluster, but I will not take each and every trace in a single cluster. I will have a multiple cluster approach. Let's go for the strongest one. Then at the 3-tier evaluation, what you know that is wrong, absolutely incorrect, completely incorrect, you just say thank you. But also if you have incomplete strategy, you have a look at the valid intermediate steps, you know, the first 60% that were correct, and you say, I keep those. Maybe there is some new approach hidden in there. And of course, the correct strategy that are fully correct and verifiable, you keep also those. Point number 4, step number 4 is then reintegrate everything that you found, you know, these partial right answers. Have a look at this. Try to have here a holistic view and design a coherent, streamlined chain of thought. A diverse, branching out, show what you can do. Look that you have kind of a logical flow, but there's now critical, there has to be here a very sensitive equilibrium, you know, because we want the system to be self-reflection, to have this self-reflection mechanism. Therefore, we have also in the training data set to learn the system. Okay, even if it's not immediately the perfect way, so we have to show you a kind of a not so perfect way, then you can reflect on this not so perfect, understand why it is not so perfect, and come back in your reasoning and find hopefully the correct pathway. And then finally, just again, have the perfect cleaning, the perfect optimized chain of thought here, have a beautiful fluency and a logical consistency, so the perfect cleanup. Just rewrite everything, clean up everything, check the overall structural integrity. So the last step here is you want check that it looks great. Now the authors of the study today used here 2 specific AI systems. They have a Q in 2.572b instruct for steps 1, 2, 3, and 5. And for step 4, they went with a GPT-4 Omni. Great. And you know what? They give us the code. They give us everything. They open source everything. And they tell us, you know, by running LLM inference using the files in step 5 that they provide for us in their GitHub, you will be able to get your optimized training data. I mean, isn't this beautiful? They give us here their complete code structure. We just have to press run. So here we go with the facts. This is the study I want to show you. This is from Alibaba Group and New York University, March 20th, 2025. Deconstructing long chain of thought. In this methodology, everything is beautiful, but have a look at this. Now I ask you why this is happening. Okay, it is 3 days ago it was published, 3 weeks the GitHub was published, 0 stars. A paper that is so interesting to further optimize the reasoning complexity of huge LLMs, how to have a significant performance improvement, 0 stars, 0 forks, nothing. Why is this happening? I think I have an explanation. They give us here everything that we need, the macro structure parsing here, the complete prompt, the parsing prompt here, the verification parsing prompt, and all the other DLCoT implementation instructions are listed in the annex. So they're really open source. They are absolutely transparent. Now, if we have now the training data, now, you know what we do. We are now looking here for optimization strategies to train then also with a notch distillation from the long chain of thought, from the huge language model, our little ones. And they go here with, yes, you know, we follow the data distillation and the supervised fine-tuning approach. Beautiful, classical way to go. Let's make it short. What are the benchmarks? And they say, okay, we go with a 6K sample data distillation result where we then find supervised fine-tune here the models. And now let's have a look at this. So they start here with two models, a QWQ32B preview. Now we have the official, but they worked still with the preview. And then we have a little QN 2.5 32B, so the same size, instruct, but this is an older model. This is a model that is not as performant and not up to the latest standards. Just look here at M24. This here has 50 and the performance indicator here is only 20. But now you know what's going to happen, huh? We say, yeah, the QWQ, this is here our top benchmark. And our QN 2.5 32B, we see the performance is not even close, no? But what happens if we take now the newly distilled data, the reasoning traces that we cleaned up, that we found the core, key, logical, minimal set of causal reasoning. And we do a distillation, this means we do a supervised fine-tuning on this QN 2.5, this little QN 2.5. Let's take a 7B. And a 7B is 11. A 14B is 35. And the 32B that would be equivalent here reaches 46.7. So you see, just supervised fine-tuning this on some specific reasoning traces, we went from 20 on the identical model, 32B size, to 46. And now we are not even far away from the top performance of 50, also a 32B. So this is amazing. You take, and let me be brief here, an old QN 2.5, you do what I just showed you here, these 5 steps. You have a supervised fine-tuning on this advanced reasoning, and your performance jumps from 20 to 46.7. That is close to the best model in class. How beautiful is this? Well, of course, you could say, for a particular benchmark like the MAT 500 benchmark, I even have a better performance than the best in class, the QWQ32B, because look, I have now almost 92 instead of 90. So this methodology of distilling down to the absolute minimum set of pure logic and then training a smaller, not as performant model on this new data set, you get a performance that is just outstanding. How beautiful is this? And nobody's thinking about it. Nobody's talking about it. Nobody is forking it. Nobody's giving it a single star. Why? Let's look at the second model. They also did the same with DeepSeek R1. Finally, beautiful, gorgeous, thank you. And we have the same benchmarks. Now they say, okay, this is the R1, so the 671B model. But let's look again at our little QN 2.5, ne? And we have the same structure, the 7B, the 14B, and the 32B. And we go up from 25, 46, 66. So the jump is amazing. And for 32B to come not close to DeepSeek R1, the official, unquantized, undistilled version, is amazing. I would be really interested if you go for a quantized R1. Let's think for an 8-bit or maybe down to a 4-bit quantized version. Are you here not close to this one here? This would be really interesting, but unfortunately I don't have here the benchmark data right now. So you see, interesting what we can do, even with an R1 model. This way to make here our smaller, not older, not so great intelligent AI model real a push and improvement. This is absolutely impressive. And nobody knows about it. So let's come here to this. So our beautiful DLCoT framework leads really to an improved model accuracy across different benchmarks, demonstrating that this distilled trunk here, this core, this spine of a causal reasoning is indeed sufficient and more efficient here for the training, even of smaller models, smaller open source model. They can become as intelligent as our huge model, let's say maybe an O1 from OpenAI. Why would nobody report this to you? And at this point in time, I said, wait a minute. Does OpenAI betray us all? And you might think, what are you talking about? You know, I'm thinking at the beginning, more than 5 years ago, we started this AI adventure. You know, I remember human-generated data set, human annotated data set. And then we had this huge push years ago to collect here all the human-generated data set, you know, this, let's say, string copy internet, no? And we went to data sets with trillions of tokens. And I really remember this particular company that was here the forerunner, no? And then we went here and we said, okay, we don't have enough human data. So we have to generate additional synthetic data. And this was the time where we had this instruction following data idea, no? Instruction following. We don't have it here from the humans, so just do it here synthetically. Then the next step was, okay, beautiful. Now that we have instruction following, we see the models are not able to reason at all. They're completely stupid as models. So what we have to do, we have to find data, a data set with a chain of thought reasoning implemented. So our AI system could say, this is a chain of thought. The user wants me to follow this kind of a reasoning structure. Please provide me with, I don't know, billions and trillions of tokens of chain of thoughts. And we did not have it. So we had to synthetically generate chain of thought reasoning data sets. And maybe you bought a new NVIDIA graphics card, no? Because you needed more power. And then we went and said, you know, it's still not enough because chain of thoughts are linear structures. So we have to go to Monte Carlo tree search algorithm, or in general, tree search algorithm. No? We have multiple branches in parallel. Maybe you bought your second NVIDIA graphic card. Maybe you uppaid to your cloud account, you know, more powerful, more expensive, because more data, more synthetic data. We're into trillions of tokens already just for a system to be able to be reasoning. And then we said, okay, it's still not enough, this tree. It says, okay, we have to go to graph topologies. We have to invest in real complex non-linear reasoning structures. And we have to go to cohomology and all the other effects that we have here, no, in mathematics. And then, yes, we could achieve some reasoning performance. And now this study brings us back. And this study says, you know what? Looking now at this from the latest monster AIs that we have, you know, if we just go for the minimal set, for the smallest set of a logical augmentation, this is enough to train even real tiny models to be more intelligent. And at this moment I said, wait a minute. So we started with human-generated data set, and now you're telling me, more than 5 years into the game, that now the ultimate ratio is to go for a minimal set of a logic chain sequence. What about we would have done this step more than 5 years ago without this? And somehow I felt a tiny little bit angry. But okay, here we are in Europe, and you know, here, there's also the other part. So for the defense, I said, okay, I talked to OpenAI. I asked here ChatGPT 03, and I had a little talk, and then asked here the question, hey, have you been betrayed by OpenAI? And it's, you know, this the whole internet data initiative. It was OpenAI who started this, no? I asked here ChatGPT by OpenAI. And it took just 7 seconds and it came back, OpenAI, and said, absolutely. I mean, the O3, it's not a tiny little system. I think, absolutely. If you think about it, it almost feels like we got a data overload gift we never asked for. OpenAI went all in with the everything under the sun internet data strategy, which, while ambitious and groundbreaking, ended up giving us a massive, noisy dataset and sometimes made our models overthink like a caffeinated college student at 3 a.m. But let's be clear, it wasn't a betrayal in the whatever sense. Rather, it was just a bold experiment. So by feeding here models with trillions of tokens from every nook and cranny of the internet, OpenAI aimed to capture the full spectrum of the human language. And this approach had its merit. After all, it produced models capable of handling a dizzying variety of tasks. But it also meant that models had to sift through an overwhelming amount of, sometimes even, imagine this, contradictory data from the internet. And the consequence? Our models started generating lengthy, labyrinthine chains of thought that were brilliant in their verbosity, but often inefficient and riddled with redundancy. Only after years of grappling with this everything but the kitchen sink methodology, did researchers finally realize that the true magic lay not in the sheer volume of data, but in distilling out that core essential logical pathway. So, rather than a betrayal, you could say OpenAI approach was an overseller's stepping stone, a necessary detour through the chaos of overabundance that ultimately taught us how to trim the fat and keep only the essential reasoning strands. In the end, we learned that sometimes less really is more. This was the defense by ChatGPT 03. And okay, a side now with the humorous part of this. Now let's come to the truth. So, what happened? The one responsible for my actions and my following the crowd and following the hype is simply just me. I did this. I'm responsible for my action. I decided, and maybe almost subconsciously, to follow here the main trend from more than 5 years ago. Just follow the crowd, Somebody was holding here a shiny little object just in front of my nose and said, you're a good boy, no? Are you not a good boy? Come on, do you want it? Do you want it? And I said, woof, woof, woof. Yes, of course, I want it. So, I read all these publications from all the different universities around the world and all the news outlets and everything. And I decided years ago to follow the crowd and go with this internet. We need all the data of the internet that our AI system will maybe sometimes theoretically in the future become a little bit more intelligent. And it is only my fault if I never thought about, is there any other option? So therefore, as you see, no, it was just my mistake, but I learned from this mistake. So let's come to an end. What does this new framework stand for? It tells us, segmenting now this long chain of thought reasoning from our huge model with all the internet data into more structured modules to isolate here the key logical pathway. This is the way to go. Pruning redundant and error-prone segment while preserving here just only the essential diversity is great, and then optimally integrate this into a now newly distilled chain of thought. This is the next powerful thing. So what we do, we go here from this methodology here, from a decompose here, the long chain of thoughts, into this new idea of a distilled chain of thought. Just a minimal key, the minimal logical path available, that thence down to the absolute minimum of causal argumentation. This is enough, even for a smaller AI system, to have the performance. If you subscribe to this channel, I have to tell you, maybe there will be another video where I will be a little tiny bit emotional, but sometimes I'm only just human.